Factoring and More Trigonometry. And then section 411 is titled Introduction to Factoring Expressions. And we're going to be answering the question, how can I determine the product? So we're going to be doing pages 1 to 3 today, but we're going to read page 3 first. If you have a highlighter, go ahead and pull out your highlighter because there's a lot of vocab on page 3. If you don't have a highlighter, you can just circle the important words here. All right, so on page 3, we have a math notes page, and it's titled Vocabulary for Expressions. A mathematical expression is a combination of numbers, variables, and operation symbols. Addition separates expressions into parts called terms. For example, 4x squared minus 3x plus 6 is an expression. It has 3 terms. 4x squared is a term, minus 3x is a term, and 6 is a term. The 4 and the negative 3 are coefficients. The 5 is a constant term, or it's sometimes referred to as the numeric term. Since algebraic expressions come in several different forms, there are special words used to help describe these expressions. A single variable polynomial is an expression that only has terms of the form any real number x to the power of some whole number. For example, 4x squared minus 3x to the first plus 6x to the 0 is a polynomial. So the simplified form, 4x squared minus 3x plus 6, is a polynomial. The following expressions are not polynomials. 2 to the power of x minus 3 is not a polynomial. 1 over x squared minus 2 is not a polynomial. And the square root of x minus 2 is not a polynomial. A polynomial with one term is called a monomial. A binomial is a polynomial with 2 terms. For example, x to the third minus 0.5x and 2x plus 5. A trinomial is a polynomial with 3 terms, like 2x squared minus 5x plus 7. Okay, so we have a monomial, a binomial, a trinomial. After 3 terms, we just refer to it as a polynomial, meaning many terms. Okay? Flip back over to page 1. And we're going to talk about factoring expressions. So question number 4.1 says review what you know about products and sums represented by rectangular area models. Examine the algebra tile rectangle at right. Write an equation showing the area as a product is equal to the area as a sum. Okay? So as a sum would be the inside. That's our xy. We have 1x squared. We have 1, 2, 3, 6 x's. We have 1, 2, 3, 4 y's. And we have 1, 2, 3, 4, 5, 6, 7, 8 units. Okay? That's as a sum. As factored, we're going to take the side. X plus 4 is the first binomial. And then y plus x plus 2 is the second trinomial. Okay? Part B says, use your algebra tiles or an algebra model to multiply 6x minus 1 times the expression 3x minus 2 and write your answer as a sum. Okay? So I took the first factor of 6x minus 1, put them in the boxes across the top, and the second binomial, 3x minus 2, along the side. And then to fill in each box, I multiplied from above and to the left. So for this first box, I multiplied 3x times the 6x, which is 18x squared. For this box right here, I multiplied the 3x times the negative 1 to get negative 3x. For this box in the lower left-hand corner, I multiplied 6x times negative 2 to get negative 12x. And for the bottom right box, I multiply a negative times a negative. So negative 1 times negative 2 is a positive 2. And then I want to write my answer as a sum. So I look for any like terms. There's no other like terms with the 18x squared, so it stays by itself. But then I have these two, and they are like terms. The negative 12x and the negative 3x combine to get that negative 15x. And then the constant numeric term is just plus 2. Okay? All right. Question number 2 says, the process of changing a sum to a product is called factoring. When an expression is written as a product, it is said to be in factored form. And each of the expressions being multiplied is called a factor. Can every expression be factored? That is, can you rewrite every sum as a product? Investigate this question by using algebra tiles to build rectangles for the following expressions. For each expression, write an equation showing that the area as a sum equals the area as a product. If you cannot build a rectangle, be prepared to convince the class that no rectangle exists, and thus the expression cannot be factored. Okay? So we've got 4 down at the bottom. We've got our A, our B, our C, and our D. So A, we've got our 2x squared plus 7x plus 6. So I filled in the 2x squared here and the 6x here. But I need to split this 7x so that when I add these two together, they will combine to get that middle term, 7x. You can build this with your algebra tiles in the CPM algebra tiles if you want. But to get 2x squared, you would multiply 2x and x. To get 6, you would need to multiply 3 and 2. That means this box should be 3x and this box should be 4x. So to write this in factored form, you can go along the top first and get your binomial of 2x plus 3, and along the side second and get your binomial of x plus 2. Okay? Now let's do part B. Part B, we have 6x squared plus 7x plus 2. So I wrote the first term of 6x squared in the upper left box, and I wrote the term of 2 in the bottom right-hand box, and then I need to figure out what goes here and here to get us a product of 7x. But I know the factors of 2 are just 1 and 2. Okay? The factors of 6x squared are 2x and 3x. So I know that 2x times 2 is 4x, and 3x times 1 is 3x. So our binomials are 2x plus 1 and 3x plus 2. All right, for part C, we have x squared plus 4x plus 1. Can't see it real well. Okay, there we go. So I write the x squared in the upper left-hand box, the positive 1 in the lower right-hand box. And I need to see what would multiply and then add to get 4x. But I know that the factors of 1 are just 1 and 1. Well, there's no way for 1 and 1 to add to get 4. 1x plus 1x would be 2x, not 4x. So part C is not factorable. Okay. D is a little bit tricky because they threw some y's in here. So we've got 2xy plus 6x plus y squared plus 3y. So I filled in the leading term into the upper left-hand box. I filled in the last term of 3y into the lower right-hand box. And then I figured out what I would need to get to multiply to get 3y. So y times 3 is 3y, and 2x and y would multiply to get 2xy. So 2x times 3 would be 6x, and y times y is y squared. So I was able to factor that one. And I took the binomial from across the top. The 2x plus y is my first factor, and along the side, the y plus 3 as my second factor. Okay? Anybody still writing from page 1? No? Okay, go ahead and turn over to the top of page 2. Okay. At the top of page 2, we have question number 3, which says, work with your team to write the sum and the product for the following area models. Are there any special strategies you discovered that can help you determine the dimensions of the rectangle? Be sure to share these strategies with your team. So the boxes are all filled in for us. All we have to do is get the factors so that we can write our factors as a product. Okay? So to get 6x squared, we would multiply 3x and 2x. To get 5, we would have to multiply 1 and 5. So 2x times 1 is 2x, and 3x times 5 is 15x. That means our factors are going to be 3x plus 1 and 2x plus 5. So you want to write it just like that as your binomial times your binomial. And then the sum is going to be our term 6x squared. And we have to combine these two like terms, the 2x and the 15x, combined to get 17x. And then the constant numeric term is just 5. Okay? Part C, just so you know, is part of it is missing from the hole punch right there. So that should say negative 12 in that box. Those hole punches, man, sometimes they just end up right in the wrong spot. So let's do C together. So for this box, for 12x squared, we're going to multiply 4x times 3x. And then to get negative 12, we would need to multiply 4 times negative 3. That means that our negative 9x would need to multiply with 3x times negative 3. And for the box to be 16x, we would have to multiply 4x times 4. So once you've factored it correctly, then you can write your binomial times your binomial. And then write your answer as a sum by taking the 12x squared, combining these two together. Negative 9x plus 16x is 7x. And then our hole punch box was a negative 12. That's our sum. Okay? I'll let you guys do B on your own. Okay. We're going to separate into our groups of 4 in just a minute, and you guys are going to do question number 4 and 5 together. So question number 4 says, while working on problem 4.3, Casey noticed a pattern in the diagonals of each model. However, just before she shared her pattern with the rest of her team, she was called out of class. The drawing on her paper looked like the diagram below. Okay, so for part A, it says, describe a pattern that Casey may have found. And then part B says, does Casey's pattern always work? Check whether her pattern works for all the 2x2 area models in problem 3. And then for the learning log, it says, describe Casey's pattern for the diagonals of a 2x2 area model in your learning log. Be sure to include an example. I want you to write at least 3 sentences for that one. And then you're done with the lesson for 411. Okay? So go ahead and pick up your desks and turn into your teams of 4.